Welcome to week two of programming with C++. Now, today we are going to look mainly at data types and their declarations. Data types and their declarations. So let's get right into it. Now, what are data types? Data types refer to the various forms data can be represented in a language, specifically C++ language. So we are dealing with C++ data types. Okay, so typical examples include the integer data type, the float data type, and the Boolean data type. Now let's move on to the categories of data types. The categories of data type. We have the fundamental types. These are basically the built-in types. The fundamental data types are the built-in types. So examples include the int, the float, the char, the bool, right? So we can say the int, the char, and the bool, right? The integer, character, and boolean. These are integral data types. They all form integral, or they all form under the integral type. Let's move on to the integral and floating point types, which are also known as the arithmetic types. So these basically include the integral and floating points types of data. That is, for integral, we've already gotten to know that int, char, bool are integral. So they also fall under arithmetic types, and also float and double fall under floating point data type, which also falls under the arithmetic type. Now we have the user defined types. The user defined types. The user defined types consists of the classes and enumerations. These are user defined, as the name implies, user defined. And then we have okay, we've already mentioned the fundamental types, the integer, the floating point, and all that. Now let's move on to data sets. Data sets. Data sets. So what what does each data type entail, or what is the content or the whole makeup of a data type? Now we see that with the integer data type, its data sets consist of whole numbers. So this is basically the entire makeup of an integer data type. That's what data sets refer to, the makeup of of a data type. What is that data type made up of? So the integer data type is made up of whole numbers. Floating points are also made up of decimal numbers with single precision. You see, the floating points, there are two types, float and double, right? Float is single precision, and double is double precision, right? And the main difference here is that with float has or float carries a less amount of significance figure, or carries less significant figures as compared to double. Double carries more significant figures. So that's the difference here. So floats deals with decimal numbers with single precision, whereas double deals with decimal numbers with double precision. And we have character. The character data type is basically the character data types or data sets. Sorry, data sets. Yes, data sets consist of letters, numbers, and symbols. Letters, numbers, and symbols. And the Boolean consists of true, false statements, whereas string is a combination of characters. String is a combination of characters. So these are the data sets for the data types. Now, in order to find the data size of any data type, we simply use the size of keyword, right? The size of keyword determines the size of the fundamental data types. So we use the size of keyword. Now, here are some basic data sizes for basic data types. So int and float both use 4 bytes. Int and float both use 4 bytes. Let's remember again that int and float are all parts of the fundamental types of data. And also, sorry, they are part of the arithmetic types of data. Yes, so it makes sense that they both use the same size, 4 bytes, 4 bytes. But double over here uses 8 bytes. Why? Because double means double precision. It's a float data type with double precision. So whatever the float, you know, is whatever the float is, the double is double of the float, right? So typical example is over here. You see floats are decimal numbers with single precision, double are decimal numbers with double precision. So that means mathematically the data size of double will be double of float. Character and Boolean use 1 byte each. Character and Boolean use 1 byte, whereas string uses 32 bytes. So string has the highest data size. Now let's move on to the integral types of data. Let's move on to the integral types of data. How are they? Well, examples are listed over here. We have negative numbers, 0, and also a positive number over here. This means that integer types, right, are basically positive, negative, yeah, okay, a positive and negative values here. You can have positive, you can have a positive value and you can have a negative value. Positive integers do not have a positive sign in front of them. You should take note of that. Also, commas are not used within an integer. And also, commas, okay, yeah, the commas are only used for separating items in a list, yes. So within the integer data types, we don't have anything like commas separating the numbers or something like that. So here is a basic C++ code illustrating an integer data type. Over here, the data type or the integer data type has been initialized. So let me quickly demonstrate that to you. So over here, I'm going to show you how to initialize a data type, specifically the integer data type. I'm going to show you how to initialize a integer data type. So I've already written down the basic structure of the C++ program, so I can go ahead and do what I want to do. So in order to initialize or even declare, we'll get to those terms, initialize and declare. So in order to declare a data type and all that, we just write down the data type, that is int, right? And then we give it an identifier. Okay, we give it an identifier. So the let me see the syntax. Okay, the syntax for initializing any data type or declaring any data type is basically the data type, the identifier, the assignment operator. That is, if you want to initialize, you introduce the assignment operator. The assignment operator is basically the equal to sign, right? So let's initialize that. So this is the data type, the identifier. The identifier can be any name, right? That you give to the data type. So in this case, X. Our identifier is X. Yes, let's go with X. Now we are initializing. So we introduce our assignment operator. That's the equal to sign, equal to sign, and then we introduce our variable, right? Since we've learned about the data sets of an integer, so we know that the integer data types consist of whole numbers. So let's put in any whole number we know. For instance, 27, right? Then we bring in our termination symbol, our termination symbol. So that's it. We have um initialized an integer data type. What about declaring of an integer data type? That's also very easy. All we have to do is follow the same syntax. But this time around, we don't bring our assignment operator. So int x, then terminate it. So we've declared our integer data type as x. So our integer data type has an identifier named x. So we can come down here and come and call out x or assign a value to x. What we've done, we've just declared it. We just let the system know that okay, I want to create a space to store an integer with the name x. Now we can go ahead and give the integer x a value which the system will also store. So you can go ahead and say x assignment operator or equal to, sorry, assignment operator or equal to any whole number. Once again, integers take or the integer data type consists of whole numbers. So let's pick any whole number 7, terminate it. You should know that our termination symbol is very important because it indicates that we've ended that line of code and we are moving on to a different line of code. If you don't bring the termination symbols, there will be errors in your code. So this is an integer data type. This is basically how to declare and initiate any data type, but this is for an integer data type. This syntax actually works for every single data type. It runs through every single data type. This is how you do it for every single data type. So since I have explained how to initiate and declare a data type, in the following or subsequent examples I'll be doing, I wouldn't explain that again because I've already explained it here. So I'll just go straight forward to demonstrate each data type and how you initialize and declare it. Alright, so let's move on to the next data type. So I don't the integer types. So the floating point types. We already know that the floating point types consist of double and float. Floats for single precision or float is single precision or decimal numbers with single precision. Double is decimal numbers with double precision. And we have long double as well, that is extended precision. Now, what about the float types? You already know that for the float types, the syntax, sorry, the data sets for the float types are decimal numbers. So let's go ahead to see how we can also initialize or declare the float type floats. And we give it an identifier. So in this case, y. Y, yes, y. Then we can go ahead to either declare or initialize. In this case, let's initialize, bring our assignment operator. Then we give it a variable or a value. So 14.9. Sorry, 14.9. Yes, 14.9. Why did I just hit 0.9 here? 0.9. Okay. Then we terminate it. So this is our float. And as you can see, the floats are decimal numbers with single precision. So that's what you see over here. Let's go ahead to also initialize double as well. So double name and we give it an identifier z. Now the assignment operator, then let's go 25.678. This is a double as well. So we've initialized a double data type and sorry, a float data type and a double data type. Let's move on to the next data type. Boolean. So for the Boolean data types, these are used to express results of logical operations. We all know logical operations, right? True, false, or, and, if, all that. So the Boolean data types are used to express results of logical operations. So they are also known as bool. They have two values, true or false. So let's go ahead to see the structure of a Boolean data type. Okay, so let's go ahead to initialize a Boolean data type. So it's also known as bool. So we put down our bool, then we give it an identifier. It's every data type follows the same syntax of initialization. So uh, it's windy, it's windy, it's windy. Our assignment operator, then true or false. That was the data set of a Boolean data type, true or false. So we terminate it. So we've initialized a bool data type. Let's move on to the next data type. Character types. Character types. Characters, as we've already come to see, are basically letters, symbols, and all that. Letters and symbols, right? So we can see them here. Now, the only special feature here is that these letters and symbols are enclosed in, single quotes, or they are written in single quotes. So that is what defines a character type. So let's go ahead to see what the character type also looks like. So let's initialize the character data type. So char, yes, that's the name for the character data type, char. Then we give it an identifier. So gender, then single quotes as we discussed, single quotes, then any letter. So in this case, since we are dealing with gender, we should use M. Yes, M. M means male. I'm a male, so I'm using M. Then you terminate it, right? So that is a char data type. Now let's move on to the next data type, string. Now, string is a combination of characters, right? So basically, string types take sentences, names, and all that. They are a combination of characters, right? So they take more than what characters take. So things such as words, names, sentences, they are for string types. But the catch is they are enclosed in double quotes. They are enclosed in double quotes. So that's the difference between the string and the character. Characters are enclosed in single quotes. Strings are enclosed in double quotes. So let's look at that string. Now let's initialize string data type. So we first put down our string. That's the data type we're dealing with, string. Then we go on ahead to give it a name. So in this case, the identifier we are using is name. Then we give it a value, or we give it a variable. So let's double quotes. Remember double quotes. Uh, let's go with Eddie. Eddie. Yeah, Eddie. Eddie. Let me make the E capital. Eddie. Right. So we've initialized a string data type. Now let's move on to the next data type, void. Now void is mostly used in functions, and it signifies the absence of information. So void, let's look at void as well. Can declare it void. So void, and just declare it. So void h, yeah. So we've declared the void data type. Okay. Let's look at signed and unsigned. What are signed and unsigned uh, data types? So, sorry, these are type modifiers. Yes, signed and unsigned are type modifiers. I want to believe they are type modifiers for integer data types. So, signed has both positive and negative values, whereas unsigned only represents non-negative values. So, in summary, signed takes positive and negative values. Unsigned takes only positive values. So let's go ahead and look at their structure. So over here, we are going to um, initialize a signed data type and an unsigned data type. Okay, so let's get right into it. So signed, then int, then give it an identifier, in this case F, or F, yeah, assignment operator, any value at all, then determinate. So this is the signed data type modifier, right? It is modifying the int data type as the explanation, or as the you know the explanation came. Yes, as the explanation came. So the signed is modifying the integer data type, and also sign can take positive and negative values. I've mentioned that before, so let's do one for negative value as well. Uh, just quickly, okay, yeah, I can just quickly make this negative. Yeah, it won't really change anything, but I'm just trying to show you that it can take positive and negative values. If I were to run this code, or prompt the console to display what I have written, and I put either a negative or positive value for the sign, right? Or if I assigned a negative or positive value for the sign, it will display the value as it is, right? But for the unsigned, if I were to use a negative value for the unsigned, the console will not display any value. Or let me put it this way, the console will display a wrong value, yes, because unsigned does not take negative values, only positive values. So the value would give me, sorry, so the console would give me any value at all. So here's the unsigned, give it an identifier D, segment operator, once again, positive values only. So there you have it. Okay, let's move on to the next thing. That is, okay, yeah, other fundamental types. So we have the short, long, and long, long, right? Long, long is used for very long integer data types, like a set of values that exceed at least six values. Yes. So let me quickly illustrate that. So you see, for the integer data type, it can think up to five significant figures or six, right? But anything beyond six, and the console will display any value at all for you, because it does not recognize the values you've assigned to the int as an int, data type. So that's where the long long comes in. So long, long, then you give it an identifier, so x. So I can assign any value of any length. Sorry, the assignment operator, any value of any length for the long long, and it's long long is still basically an integer data type. So yes, only positive numbers, only positive. Hey, not positive numbers, only whole numbers. Yes, that's what I wanted to say. Only whole numbers, only whole numbers. So you can go ahead to yes. So as you can see here, this, sorry, then we add ll at the end. Yes, that is the syntax for long long. After you write the, or after you assign a variable to it, you add ll, then you terminate it. So this is what I was saying. So if you write the same value down, or you assign the same value down for the int, if you are to display it in the console will not display this value for you. That is, if you have to use this for int. So in order to write down values like this, or print out values like this, you need to assign it to the long long data type, or you need to use the long long data type in order to print out values like this on the console. Let's move on. We have composite types as well. These are the pointers, the arrows, and reference types. We'll go more into that in our week 3. User defined data types, as I mentioned earlier on. These are the classes and enumeration data types. Declaring multiple names. So we can also declare multiple names in C++ programs. So let me quickly demonstrate that for you to see. So you see how I have done, or I have written down, or I have illustrated for the integer data type. Yes. Now, if I wanted to, assign two identifiers or two variables to an integer data type, right? There are two ways I can do it. So let me quickly demonstrate that to you. Let me comment this, comment all this so that it's not affected. Okay. We will learn about commenting soon, so don't worry. We'll learn about commenting soon. So that's I've commented it, right? So let me quickly demonstrate what I was trying to say. So if I wanted to assign two variables to an integer data type, there are two ways. It's either I do it like this. See what I've done here? I have given this integer data type two different identifiers, and I've assigned two different values to it. I've assigned two different values to it. If I wanted to, make this simple, right? I can do so by declaring it or initializing it using multiple names. Sorry, declaring it using multiple names. Yes, declaring it using multiple names. So this is how you do it. So instead of, you know, you okay, you know, let me just start again for clarity. Okay, so let's stick to declaration. Let's stick to declaration now because it is multiple names declaration we are talking about. So let's stick to declaration. So I want to declare, an integer data type, right? Let's say I want to declare two integer data types. So there are two ways I can do it, right? So the first way is I'll declare one and come down and declare the other one, right? But if I want to make it simple, I just use multiple name declaration. So what is multiple name declaration? Let me show you. Our data type, our first identifier. Then we can separate it by a comma, right? We can separate it by a comma. Then we bring our second identifier. Then we terminate it. So it's either we do it this way by declaring both separately int x, int y, or we use multiple name declaration. You declare all in one line of code. That's what you've done over here. So it's easier to use the other one, the option number two. Let me highlight it. Yes, it's easier to use this one, this very one, uh, than to use the other two. Why? Because it will save you time. Save you time. So that is multiple name declaration. Let's move on to scope. Now for scope, we have um, global and local, as well as class, namespace, and statements. But in this case, local and global is what you are going to be focusing on. So let's quickly look at that. So uh, I'm going to, show or demonstrate to you the global scope and the local scope. So let me quickly go to my code blocks. Like comment this. Okay, let's just. So for the global scope, we are defining or initializing or declaring the data type outside of the int main function, right? So we are doing it over here where we have our include IO stream using namespace SSD. That is where we are going to, declare or initialize our data type. When we do so, then we've done it in the global scope. We've done it in the global scope. So let's go on ahead to do that. So let me just quickly initialize an integer data type. Let's go with B, and assignment operator 78. Yes, so we've initialized int B, or we've initialized this integer data type in the global scope. Now, when we initialize or declare the data type within the int main function, that is within where we've done all this, then we say we've declared or initialized it in the local scope. So all what you've done here is in the local scope. All what you've done here is in the local scope. What you did just right now is the local scope. And then what we just did here is in the global scope. It's outside the int main function, so it's in the local scope. I'm sorry, the global scope. Yes, the global scope. So that's it for global and local scope. And then we've spoken about declaration already and initialization. I've demonstrated that earlier on. So that brings us to the end of our video. Catch you in the next one. That is week 3. So stay tuned.